Okay, good morning, everyone. Again, the same question. I'm visible. Whatever the things are there, they're visible, and I'm audible. Okay. Anyone can answer in chat. Everything is fine. We can start. Hello. Is it properly audible? Okay. Now, the thing we have discussed earlier, that is regarding calculations. Okay, so I think up to this particular point we have come. Is it? We have taken the boundary conditions, and based on the boundary conditions, we have found out this particular equation. Is it right? So that I can start with this particular point. Only BOD is covered. Okay. In case, okay, okay. We haven't covered these problems. Okay, these problems are covered, right? So this particular condition we haven't covered, right? Regarding this one, this particular problem is covered. Okay. So we have, I think we have come up to this particular point, right? The problem. So, only one problem. Okay. So the thing is that we have gone for this particular part of a BOD. In a BOD again, we have seen that how the BOD is been determined, and based on the determination of the BOD in the lab, uh, there are various restrictions. Out of those restrictions, we have solved the problem regarding the restriction. We have solved the problem regarding the restriction, that whatever the uh, wastewater quality is there, that the wastewater strength, we can say, the wastewater strength we have gone for this particular observation, that is initial observation we have taken, the final observation we have taken, and it has been multiplied with the dilution factor, because dilution we have to carry out. If it is not, then wastewater strength, because of the wastewater strength, we may get this zero reading. Okay, and based on that, we have calculated the BOD in the standard condition, that is 5 days and 20 degree, this one, temperature. So likewise, this one problem we have covered yesterday. Now the next problem, again, 2 3 problems are there. We'll be covering those various problems again. Those things are based on previous understanding. So please do have a proper understanding. Again, in every lecture, I would suggest you to have pen and paper, so that it is quite possible for you to prepare your notes, prepare and carry out your calculations. So you do have, be ready with your calculator too. Answers would be given, no doubt, but still you have to carry out the details, so that it would be easier for you to understand. So the thing is that uh, the next problem is this one. Okay, now in this particular problem, that the direct answer has been given. So in this the basic problem is, initial observation, that is initial DO of the mix is 8. Okay, final DO of the mix is 2. That means what? This is the standard condition we are going for, that is 20 degrees Celsius and 5 days incubation. So we would be keeping that sample, and that sample is giving us this particular result. Okay, that is 8 milligram per liter initial dissolved oxygen, 2 milligram per liter dissolved oxygen after 5 days and 20 degree incubation. Okay, now the problem is here. The problem is given that whatever the this dilution is there, that dilution is being carried out with 2 ml wastewater, 2 ml sewage. Okay, so volume of sewage we are utilizing is 2 ml. So that is why whatever the dilution factor we would be utilizing, the dilution factor would be in 300 ml bottle, 2 ml of wastewater we are utilizing. That is why this particular dilution factor would be there. Okay, so this particular dilution factor we are utilizing, and because of that, this subtraction is being multiplied with this particular dilution factor, so that we are going to get the strength of wastewater in terms of in terms of BOD. Okay, the biochemical oxygen demand of that sewage is 900 milligram per liter. Why? Because initial observation is 8, final observation is 2, which is the observation of that particular mix. Okay, why that? How that mix is being carried out in 300 ml bottle of the distilled water. We have added 2 ml of sewage, that 2 ml of wastewater. So this particular dilution factor has been carried out, and based on this particular dilution factor, we have gone for this particular answer. Okay, if the dilution factor is not there, so the sewage is not that's strong, then direct 8 minus 2, we would get that answer as 6 milligram per liter. That is the strength, that is the demand. Okay, so right now the demand is the oxygen demand is 900 milligram per liter. Okay, so if you have any doubts, you can put it in the chat. Okay, so we are solving the examples. Now the next one is the next factor is very necessary, very important. Whenever again the next problem is that the problem is the uh, wastewater is taken. Okay, now in case of wastewater, again we are going for this particular dilution factor. Okay, so direct dilution factor is been given, and the initial observation is taken. Now this initial observation is initial observation of mix. Okay, direct mix is been carried out, because whenever the dilution factor is there, that means what, whatever the solution is there, that solution is mix of distilled water and sewage, or distilled water and wastewater. Okay, so that particular this one is that mix. The initial observation is 7 milligram per liter. Now next one is very important. The final observation is 0. Okay, now in case whenever the final observation is 0, that means the whatever the test we have carried out, that test is now a test is failure. Okay, test has failed. Why? Because whatever the observation we have gone for now, in this case, dissolved oxygen dissolved oxygen initial is 7 milligram per liter, but after that, whatever the process is been going on, that in that particular process, that organic matter has to be consumed for remaining 5 days. Okay, in 20 degrees Celsius, that particular incubation. So whenever it is been carried out, and afterwards it should have certain reading. If it is not having certain reading, that means what, we cannot guess that at what point the organic matter, or at what point that dissolved oxygen has become 0. Okay, so this means that our test, whatever test we have kept for, that test is not it is a failure. Okay, it is not giving us a correct reading, right? So when that dissolved oxygen became 0, we don't know. It might have become 0 after 1.5 or 2 days, 3 days, we don't know. But it should give us reading after 5 days. Okay, so dissolved oxygen has to be there after 5 days. If it is not there, if it is not giving us a result, then that test is, we can directly write down that test as failure. Okay, so even whatever the dilution factor, if everything is there, the test is failure. The test is not going to give us any result. Okay, so it is the test without any result. This is the we can say, we can have the conclusion of this particular test itself. Okay, so why again, again the thing is that here we have got here let us take this particular problem. In this particular problem, the initial reading is there, final reading is there. Initial reading is 8.5, final reading is 5.5. Okay, so here we can say that initial dissolved oxygen is 8.5, and final oxygen is 5.5. So the oxygen is remaining over there. So oxygen is going to give a certain reading, but in this case we don't know at what point that reading has oxygen has come to 0. Okay, so that is why we can say that test is failure. That's why whatever the test is there, that test has to be carried out again, right? So for that particular wastewater, we have to carry out that particular test again. Okay, so the estimating BOD, we should not carry out the estimation of BOD with just one test. So right now, just for the sake of the problem, these are the details which have been given, and based on these details, we have found out the results. Okay, but whenever we are going for laboratory estimation, in case of laboratory estimation, we should not go for just a single reading. Okay, so we have to go for the multiple readings, so that after getting the multiple readings and multiple dilution factors, then we will be coming to a one solution. So even whenever we are going for we are utilizing a single single sewage, and if even if you are going for multiple dilution factors, the result is not going to change. Okay, but we have to carry out those things, so that it would be easier for us, or whatever the results are there, those results should not be a failed results. Okay, so initial result oxygen it is going to give, afterwards after 5 days, result should not be zero. Okay, so one problem I'll take, the problem is like this. So this should be understood. First of all, whenever we are going for estimation, or determination, you can say, in the case of determination, dissolved in oxygen initial is going to give us some certain result, but dissolved oxygen final, if it is zero, there itself we should not go for any kind of calculation. There itself we should write that test is failed. Okay, whatever the dilution factor is being utilized or not, even the dilution factor, if it is not utilized, even in that case, the whatever test is there, that test is failed because of this particular zero result. Okay, so the thing is that the reason is that we don't know at what point that dissolved oxygen has become zero. So that is why we cannot estimate that at this particular point the result has been zero. Okay, dissolved oxygen has been zero, so we cannot estimate that. So that is why that test is failed, and the failure of the test is because of the dilution factor. So whatever the dilution factor is there, that dilution factor has to be more. So in this case, dilution factor is 100. That means whatever the sewage strength is there, that sewage strength we haven't estimated. Whatever the sewage or wastewater is there, that wastewater is strong, and because of the strongness of the wastewater, whatever the organic matter concentration is there, it is more. And because of that particular more concentration, we have to disperse that particular organic matter. And whenever the dispersal, if it is required, that means what, dissolved oxygen, sorry, this particular dilution factor has to be more. Okay, so dilution factor here, it is been taken as less. That is why the uh, we can say organic matter is more, and in that case, dissolved oxygen, whatever the dissolved oxygen which has been available in that bottle, that is not enough for consumption. Okay, and because of that, it has become zero. And at what point it has become zero, we don't know. So that is why there itself we should write that whatever the result is there, that test result is failed. Right. Now the problem you can take. So you can take. I'll illustrate you, first of all the problem. Then you can take it down. Now the thing is that there are 4 5 columns. First column is of sewage volume. Okay, wastewater volume. Second one is observation. Third one is observation. Next one is a dilution factor. Okay, and the last one is the result calculation. Now, these observations are for only one type of wastewater. Whatever the wastewater is there, that wastewater. Okay. So that particular wastewater, we have taken that particular sample. After taking that sample, we have prepared three solutions. Okay, same sample has been taken, and we are preparing three solutions, because we don't know what this dilution factor would be applicable. So that is why we are carrying out the test only for one wastewater sample, and that test would be carried for three samples. Okay, so the same sample we are going to take, and the same sample is been applicable for these various volumes. Now we'll take 300 ml bottle. All 300 ml bottle will take. So, at this particular point, we'll be adding 295 ml of distilled water, and 5 ml of sewage. Okay, second one, we are going to add 290 ml of distilled water, 10 ml of sewage. Okay. Next one is in third one, we are going to add 250 ml of distilled water and 50 ml of wastewater. Okay, so likewise, these various combinations we have done, and again the sewage or wastewater is same. Okay, so the dilution factor, just we are varying the dilution factor. Even in case we can take the whole sample also. Okay, but right now the three samples have been prepared. Now after preparing these three samples, now dissolved oxygen of mix we are going to calculate. Now dissolved oxygen of the mix. How to calculate the dissolved oxygen of the mix? Here, uh, just in previous testing we have gone for. Now this one dissolved oxygen initial we are calculating. Right now the dissolved oxygen of the mix is being calculated as volume of distilled water and dissolved oxygen of distilled water plus volume of sewage plus multiplied by dissolved oxygen of that particular sewage divided by volume of the distilled water plus volume of sewage. Okay, so if, by this formula it is quite possible for us to calculate the dissolved oxygen of mix. Okay, so the dissolved oxygen of the mix means this one. So volume of this one, volume of sewage and volume of distilled water. So this particular volume we are going to carry out as variation. And whenever we are carrying out this particular variation, that means what? Whatever the dissolved oxygen is there, that dissolved oxygen would be having variation because of the addition of this volume of wastewater or sewage. Okay, so in this manner, there are these results we are getting. After adding 5 ml, this is the dissolved oxygen of the mix. After adding 10 ml, this is the dissolved oxygen of the mix. After adding 50 ml, this is the dissolved oxygen of the mix. Okay, so this is the observation on 0th day. The initial observation dissolved oxygen initial we are getting as 9.2, 9.1, 8.4 for these combinations. Okay, for addition of 5, for addition of 10, for addition of 50 ml of sewage. Now these samples, there are three samples now, 1, 2 and 3. Now these three samples we are going to keep for incubation again. That incubation is 20 degrees Celsius, and that would be again kept for 5 days. Okay, after 5 days we are going to take out those bottles, and then we'll be determining the final DO. Now after taking this particular first sample, the first sample is we are getting the result as 6.9. So final dissolved oxygen we are getting here as 6.9, right? In the second one, the second in second case we are getting the dissolved oxygen as 4.4. Okay, now in third case the dissolved oxygen we are getting as 0. That means this particular sample, whatever we have kept here, that sample doesn't is failed. Okay, test is failed. It can be determined. So here itself we can write the test is failed. So earlier it was a thing that we were carrying out three samples and we were getting average of three results. Now the one test is failed. That is why whatever result we are going to carry out calculate over here, we are going to take average of these two results only, not the third one, because third one is test is failed. It is not 0, mind it well. The third one would be the test is failed. Okay, so as per the volume added, dilution factor has been calculated. So 300 5 ml in 300, 10 ml in 300, and 50 ml in 300. So those dilution factors are here, and based on those various dilution factors we are getting the results. Okay, so result would be calculated as the initial DO minus final DO multiplied by dilution factor, right? In this case we are getting this one result: initial DO minus final DO multiplied by dilution factor. This is the result. Okay, so whatever the dilution factor we may vary, the results would be always same. Okay, so in this case we can observe these are the results. So this is first result, second result. So because of the third result is failed, that is why we are going to take the average of 2. So first result, second result, average of those actual average BOD of that sewage is 139.5. That is the case. So if this is one understood properly, then you can take it down as the problem in the problem that sewage has been taken, and those that sewage is taken for these various variation of volume. Okay, and these are the observations after, before and after. That is initial observation, final observation, and then you can go for the calculation. So directly this particular chart, if you take, you are in the position to understand it. Okay. But every now and then, even whenever you would be referring it afterwards, you should be in a position to understand it. So that is why, if it is possible for you to write it down in words, please write it down in words, and then you can take it down this one, and then calculation you can carry out, so that the result would be this one. Okay, so I'll give you 1 minute for that, so that you can take down the details. Till then, if you have any doubts, any problem, if it is there, you can put it in chat. Let's guess that there is no problem. So we can go further with this one. So it should be understood that whatever the results we are going to get, final result, if it's zero, then we should write that as a test is failed. And the observations here, you can see the initial observation we should have, final observation we should have, and based on that, based on the dilation factor, we can get our BOD, that is biochemical oxygen demand. Okay, so here you can see in general the average biochemical oxygen demand of that particular seepage would be about 139, 140 milligram per liter, right? So that means what? Whatever the wastewater is there, that wastewater 1 liter, if you are disposing that particular wastewater, it is going to consume about 140 milligram of dissolved oxygen. That is the calculation. So in this manner, we are going to see that whatever the wastewater which has been generated in a town or in a city, that particular wastewater is to be disposed, and during the disposal, how it is going to have the effect on that particular disposal site. Disposal site would generally would be a river. So if it is over, then we can go for the further part. Okay. In case of further part, uh, further part is a kind of is model. Okay, BOD model. Now, whenever we are concerned about these observations, again we'll see about this particular thing. Whenever we are concerned about certain sewage problem, then every time we have to go for these observations, various observations we have to carry out, and after we are getting those various observations, then it has to be estimated that how what action we have to take. That is, in case of we can say treatment, what treatment has to be carried out. Okay, so every time we have to be dependent on these particular laboratory results, so that it is going to give us idea that how much is the strength of the wastewater, and based on the strength of the wastewater, then we have to go for the treatment. Now, practically, if you see, again, practically, what we have done, we have taken instead of 22 days, we have taken 5 days results. Okay, 60 to 70% results. Even after getting those 5 days results, but still, practically, on the day one, if the wastewater is available, we have to take action, or we have to carry out some kind of treatment, or we will come to know about the idea of the wastewater strength about the fifth or sixth day. Okay, so in this manner, practically it would be very much difficult for us to take some action, so that the treatment of the wastewater is being carried out. So for that particular reason, we have to go for some kind of model. Okay, so that is the mathematical model. How the mathematical model would help us? that whenever the various results are being taken, and based on those various results, we would estimate so some initial observations we can have, and based on those various initial observations, then it is quite possible for us to put those results in that particular model, and after getting some result from that model, then here itself it is quite possible for us to estimate that on day one, that these are the results, these would be the results after 5 days, and based on those on the dates day one itself, it is quite possible for us to take some treatment action. Okay, so for that particular reason itself, the mathematical model is being developed. Okay, mathematical model generally would be developed for this particular reason. So in various subjects, the mathematical model would be there, and out of those, in case of environmental engineering, the mathematical model is it's been developed, and that is because of this particular reason. That's whatever the treatment is there, that treatment has to be estimated. Sorry, treatment has to be carried out, and for carrying out that particular treatment, the result has to be estimated. Okay, so for estimating those results, the mathematical model has to be carried out. Okay, so that is why we are going for this particular mathematical model. There are 2-3 mathematical model I have included in a syllabus. Out of this is the one, the mathematical model we are going to see. So this particular model is going to give us idea regarding what would be the BOD. Okay, some observations we'll take, and based on those various observations, we can estimate the BOD. Right now, if you go on the field, in case of the field, these are the various observations we have to carry out. That means what? First of all, we have to collect wastewater. Okay, after collecting the wastewater, then we have to carry out these three of in this particular case, we have to go for these three sample preparation of the same wastewater. Then again we have to go for this initial observations of all the three samples. Then the final observations, whatever the dilution factor is there, we have to estimate that what would be the dilution factor. Okay, so in some cases it may happen that if the strength of the wastewater is more, then even in this whatever the dilution factor we have selected, those dilution because those dilution factor with those dilution factor the test can be failed. Okay, in all three cases the test can be failed. So at that particular point, whatever the results we are going to get, or whatever the thing we have carried out, that can be failed. Okay, we don't get result based on that particular part. So this may happen. It all depends on the kind of experience the environmental engineering or engineer do have. Okay, but still we have to carry out this whole work, and then get the result, and then we have to go for this one treatment aspect. But instead of that, some initial results we can take, and we can go for that particular model. So before going for that mathematical expression of that model, we have to understand first of all. Okay, so certain things we have to understand, and those things are being represented over here in terms of graph. Okay, now these two graphs are exactly opposite. Now the first graph you can observe, right? So in first graph here, the two things are being given. On x-axis there is time. In case of BOD, time would be always in terms of days, because the details, whatever the organic matter is there, that organic matter would be consumed within days. It is not, it won't be less than days. Okay, so it would be definitely in terms of days itself. So time would be in terms of days. Now second, on y-axis we do have organic matter. Okay, now what we'll do, we'll observe how that organic matter is being consumed throughout these various days. Okay, now if you take the sample, if you observe that how much is the organic matter, the maximum organic matter here, we can estimate, we can determine. Okay, so maximum organic matter here is L0 right now. So that particular organic matter is being present at day 0. That is the case, right? Now, if you keep the sample as it is for incubation, you can say, then in case of incubation, what happens, that whatever the organic matter is there, that organic matter would be consumed. Okay, so this one is the consumption of the organic matter. So during that particular process, the organic matter would be consumed. So here, this particular part, suppose this is the end of the that test. During the end of the test, it may happen. Okay. Any doubt? Any problem is there? Okay. Hmm. So in case of this particular part of in case of this uh, part of this one, organic matter. Now organic matter would be there, and that organic matter is going to be consumed, and this is the end of the result. So again, we can estimate that is about more than 22 days. This particular part would be, that is organic matter, would be getting less and less, and it would be somewhere here it would be zero. Now we are more concerned about how is that organic matter is being consumed. Okay, and then we'll be estimating that how much is the it is going to put oxygen demand on it. Okay, so now here you can see that generally we take that at any point t. Okay, so let us see, let us take as at day fifth day. If this particular observation, if you take, then this happens that about 60 to 70% organic matter has been consumed. So here you can see at this particular point, this particular matter is been present. So this one is the organic matter which has been present. So organic matter which has been removed or consumed, we can say it is from maximum to this particular point. So LT is remaining. That means what? L0 minus LT. This particular organic matter is removed. This particular organic matter has been consumed. Okay. So this is the observation, or whatever the BOD we are calculating. This is dependent on this particular factor, that is L minus LT. L0 minus LT. So maximum organic matter has been present, and the organic matter which has been present after a certain day. So right now we are concerned about BOD. So we'll take observation. Let us take for our understanding. We'll take this T days as fifth day. Okay. So after 5 days, this is the case, right? So this you might have understood. Okay. So the observation and organic matter consumption we have represented on this particular graph, right? Now during the consumption of the organic matter, at the similar time, at the similar point, there is consumption of oxygen too, right? Now the same is being represented on the other graph. Now this one is the other graph. On this particular other graph, the time in days. Now on y-axis we are going to represent how much is the biochemical oxygen demand, how much is the oxygen is being consumed, right? So here you can say at L0, at this particular point, at time 0, sorry, at L0 means maximum this one, maximum organic matter present. Now whenever the maximum organic matter is being consumed, so that means this is the organic matter which has been consumed, then you can say at this particular point that organic matter has been consumed. That means what? Ultimate BOD. That means maximum BOD has been available at this point. That is the case, right? So that is why it has been called as BOD ultimate, or BOD subscript U, right? So BOD subscript U, if it is written, then that means what? The BOD is been present ultimately over there. Ultimate BOD has been present over there. Now at this particular point, that means at time 0, here 0 days, whatever the or this we can say organic matter consumption is there, that organic matter consumption is 0. That means maximum organic matter is been present, right? And from this particular point, there would be consumption of oxygen. As the consumption of organic matter takes place, there would be consumption of this oxygen, and because of the consumption of the oxygen, you can see here the graph is been increasing in this particular manner. That means what? Whatever our oxygen demand is there, that oxygen demand is increasing because of the organic matter which has been consumed here, right? So that is these are the two graphs you can say, which we can have the overlapping of these two graphs. Most of the books you would get the overlapping of these two graphs. Okay, so overlapping is somewhat confusing. That is why I have got you these two graphs separately. But otherwise, there would be overlapping of these graphs. Okay. So in this case, again, we'll take the example of T. T number of days, that is fifth day. On the fifth day, what happened is this much is the uh, oxygen demand. That means this was would be a BOD. Okay, so YT would be the YT, that is Y5. Okay, on fifth day, this one would be the oxygen demand, right? So this is the oxygen demand. Why? At time T, this one would be LT consumed. Now, organic matter consumed or organic matter removed is, this is the maximum organic matter, and this one is the organic matter which has been present at day 5. So L0 minus L5 would be this much is the organic matter which has been present over here. So whenever this particular organic matter has been consumed, that means what? At that particular point, this is the biochemical oxygen demand over there. Okay. So this again, as the organic matter has been consumed, the further demand of oxygen would be there, and that demand would be increasing up to ultimate BOD, right? But we are not going for ultimate BOD. We are going for this particular part, that is at 5, at day 5. What is the concept? What is the condition? Okay, so this one would be the condition, that is biochemical oxygen demand. We have to measure from this end to this end. This is the biochemical oxygen demand, right? So that biochemical oxygen demand is Y5. Okay, YT or Y5. Okay, so Y5, that is Y after 5 days, biochemical oxygen demand after 5 days is this much. That means what? The organic consumption after 5 days is this much. Organic consumption after 5 days is L0 minus L5. So these are the two graphs we have to always remember, we have to take into consideration. And then if you understand well, then you can have the overlapping of these two graphs, so that one graph you would get in this particular manner, second graph you would get in this particular manner, so that there would be intersection, and that intersection you would to get it as the LT and YT, which has been you're getting at the same point. If it is possible for you, then do it. Otherwise, always do have the representation of these graphs separately. So one graph we are getting for organic matter consumption, second graph we are getting for BOD, which has been required. Okay, at the same time, the BOD requirement would be, so BOD requirement in terms of milligram per liter, organic matter again it would be in terms of milligram per liter per this one. So in this manner, the graphs are there. Those graphs are to be understood, and then we can go for the further mathematical expression, right? Please do have doubts been asked, then we can go for further explanation. So the thing is that whenever we are going for any these one calculations, whenever we are going for utilization of any model, we should understand the basics. So um, I can estimate that you've understood the various basics regarding the BOD part, okay, biochemical oxygen demand part, and based on that particular BOD part, it's quite possible for you as a hydraulic engineer. Okay, you are going to go for as a work as a hydraulic engineer. It may be private, it may be government. So in both the cases, you have to go for these various calculations. Otherwise, what happens that I have seen on the site itself that most of the engineers do have that particular position, but they don't know about the part which is how to estimate. Okay, so the estimation and everything has to be proper, so that you understand here itself, so that it would be easier for you to utilize this particular knowledge there. This is one thing, and second one, at various levels, APC, MPC, whatever, this one, the percentage of anomaly engineering is more than 33%. So every time we have to go for these various calculations. So theoretically or practically, we have to utilize these various things, so that it could be useful for you. So please do have the usefulness of this information. Okay, and then we can go for further calculations. Further calculations are based on these basic understandings. Okay, so BOD model is we are going to have the BOD model for that. It would require a certain time again. So in the next lecture we'll be carrying out that particular part, right? So right now do have the concentration of this particular part, that is the graphical representation, how the organic matter has been consumed and how the BOD, that is oxygen demand, is been there. Based on these two things, then it would be possible for you to represent these various these one terms. Now this one term is L0 is the maximum organic matter which has been present. LT is the term which has been utilized for the organic matter which is present after a certain period, the time t, after time t. Okay, so if it is 5, then L5, it would be L5. So L0, the initial organic matter present. L5 is organic matter which is been present after 5 days. L0 minus L5, that is the organic matter which has been removed uh, uh, during the 5 days. Okay, so that is the case. Here the t again 5 days. YT, it would be BOD. BOD 5, after 5 days the BOD, what is the biochemical oxygen demand? The oxygen demand is increasing in this particular manner, and at this point we can have the determination of the BOD, biochemical oxygen demand, so that you can get the value that this one is the amount of oxygen which has been required. Okay, which has been required in that particular wastewater after disposal to remove organic matter. That is the case. Okay, so BOD model, that is why the mathematical model we are going for. In this mathematical model we are going to utilize based on these particular factors. Based on this understanding, we can go for further things, further expression of mathematical model of BOD model, right? So if you have any doubt, you can ask those doubts over here. Otherwise, we will be concluded. We are concluding the lecture here because it is 9:51 now. So thank you for attending the lecture. The next lecture will be starting with this particular mathematical expression, and based on the mathematical expression or BOD model, that particular model will be solving examples. Okay. Thank you. Again, if you have doubts, please you can have ask the doubts. Otherwise, you can leave.